Having a good product idea is awesome, but the economics behind that product is much more important. Can it be made quickly, in quantity, with enough margins to pay off investment, pay people, and have extra for growth? Since we already have a workshop, I thought it would be so easy to manufacture these bikes because we intentionally made them to make it easy for ourselves. But complexity comes when setting up for production. So every single piece is in a top quality and is exactly the same. The issue is that the small companies like us compete with big companies that have been established for years, that have hundreds of engineers fine-tuning every single detail for years. So that creates a very high standard for customers, and they are less forgiving with imperfections. I want this space to have a smooth working dynamic, quick decision making, fast manufacturing with assembly, testing it out, finding the mistakes, then improving them. Jumping on outsourcing too quickly is very inefficient because we don't have the direct feedback how to improve things. So first few models making ourselves is the direct loop of a feedback. A CNC laser cutter was an essential tool for us to make a complicated, high-quality product. With it, we can fine-tune every detail ourselves, and once it's finalized and ready for manufacturing, we simply provide plans and instructions to external companies. This certainly is another big milestone for us when we have proper rust treatment on this bike. And now we're gonna use an epoxy primer, then paint, then lacquer to cover it all up at the end. It's gonna be amazing. In general, metal is hard to shape. It takes a lot of effort, tools and labor. With a CNC, we avoid cutting by hand, drilling holes, sanding, and custom shaping the many parts needed for our product. My attention is always so scattered that I wish to count on all the issues coming with a laser. It always builds up in so much complexity, costing money and time. Like dealing with heavy metal sheets, like dealing with scrap material, all the gases, and even the grit. Some of these heavy sheets I would have to plan ahead of a time when I want to cut something, for example on Saturday, to load it with my guys on Friday, because then what do I do alone with this? This is like 130 kilos. And always whoever is cutting on a CNC, like, hey guys, can you help me with a sheet? And for heavy sheets, taking a forklift, wow, it's just too time consuming. I had no idea I will need a lift. With this crane, one of us can pick up a heavy sheet alone. I thought about building one, but that would get us stuck for 2 weeks. I have no money for a new one. It's always tough to finance this early stage of prototyping. So I found one online, knew it doesn't fit, so I had to modify it. And now it's amazing how much of a breeze it made us to produce. Isn't it satisfying how it clears the pillar here? Then it clears beautifully this tube rack, and I can actually lift up sheets from here. And the same thing, it extends all the way to behind the CNC. So I'm actually planning a little scrap material storage there too. So this is the part I had to cut off because I knew it won't fit height-wise. I had to draw this and weld it to the top, lower the rod a little bit. And then we figured the range is not good enough, so we had to extend a little bit on the length. And obvious choice how to help it a little bit with extra load. was adding the counterweight. So now we have a big benefit of loading sheets straight from the car outside and placing them on a storage rack we don't have yet, and then on a CNC. This is a strong magnet capable of lifting 300 kilos. With a lever, I activate or deactivate the force. We have two modes on this, fast and slow, up and down. I attach the magnet to the sheet, press the button and lift it up. When planning the CNC purchase, I had no idea we might need a crane. But that's how it always builds up on the top of each other. I certainly started planning more projects on this CNC machine because of how convenient and fast it is, how much it helps us. So it opened up my whole designing abilities, and I use it whenever I can. For example, for this extension we built on the top of the workshop, we just used the square tubing for the base as a spine. Stairs felt like mining tiles from one big sheet and welding them straight to the structure outside. I think we needed 16 of them. That was pretty cool. Don't worry, these stairs are not finished, that's only the first stage of them. Pretty quickly we found the limitations with the laser, that it actually only creates 2D in a 3-dimensional space. And that's very limiting. What do we do with this? A press brake is a simple device allowing us to control a lot of force for repetitive bending. It only moves up and down and controls the force based on the metal and required bending angle. It's CNC, so it is computer controlled. We can set up programs for different bending sequences, so the bends are always the same. This metal sheet is so thick that you can't bend it in your hands. The bend would certainly not be on point squared like this. With this, we can make as many as we want in just minutes with one just like the other one, 1/10 of a millimeter accuracy. I did not feel like spending so much money for a simple device like a press brake is. So in my typical fashion, I took a risk and bought a second-hand machine that ended up not working. The computer worked, and I know that's really expensive to replace, so I at least have a value in that computer. It was thought out well at the beginning, thinking I can just find the right mechanic and let them do the job and make it work. Well, I tried the first one, the second one, then third one. The third one seemed to be capable enough to do the job, but there was an issue to get a wiring diagram from the machine. Then it was this and that, and it really ended up to 6 or 7 months of not running and just sitting in our workshop. But now it works. Now we have it, so now we can set up our programs for every single part we need and have it done within few minutes. In few steps, we make something 2-dimensional into an awesome 3-dimensional structural part that we can use for our bikes. Yeah, well, as we go, we make a system around these machines. So we have a tiny little shelves, a few things pre-made there. And in a spare time, I am learning as I go to quickly acquire new skill, how to think in laser cutting and press brake bending at the same time. What I can do, how to do it quickly, and absorbing this new skill set. Obviously for the Havoc production, we can finally make what I wanted from the beginning. Fully enclosed, sealed, well-protected boxes for these high current batteries. I know this is gonna last a lifetime. I could not have predicted how much time a simple thing like this would take. A whole new universe of complications came with mudguards. Originally I thought we would buy ready-made and simply install, but I learned there are no reasonable off-the-shelf options for us. Okay, we can make it. We did 3D printed mudguards in the past, but I know it's not ideal. They need to be thick to have structural support, and in this case I would like to have something thinner, lighter and more stiff. Injection molding seemed to be like a good idea until I learned how much it actually is to create a mold. I was quoted $15,000 US, which was absolutely out of our budget. So back to the drawing board and try to figure out a more affordable option to make them. I like that we always come up with these practical solutions. It's so expensive to do injection molding, but this is so beautifully simple. We can just take an ABS sheet, vacuum press it, cut it out and have pretty reasonable mudguards for our bikes, custom made. I've known vacuum forming for a long time and I've always wanted one. Now it seems to be like a good excuse to finally build one. And it's actually much simpler than I thought originally. So I CNC cut aluminum to create a plate for my base DIY vacuum press. I just heated up the plastic sheet with a propane torch and then used 2 vacuum cleaners to suck the air out. The mold for the front and rear mudguards are made out of MDF. I really cut them, shaped them, sand them, and they look pretty decent. It might always look simple at the end when you see the final product, but the amount of mental energy it takes to figure things out, that's always micro problem solving. There is certainly a lot of unexpected hustles we didn't even cover in this video. Luckily, I really enjoy what we do here, and I just like pointing out how sometimes difficult and unexpected issues surround following the dream and making it into reality. It's a lot of fun to create something that doesn't exist, that brings a lot of value and a lot of joy to people. It's fun to see how people react to it, it's fun people test riding this, and it gives me a real joy.
Ježiš, to je divočina. Je to chvíť nabít.
Já myslím.
To je brutální. Jako je to brutální. Neříkám nic.
As you can see on this channel, we constantly make a lot of cool stuff. Also, as you can see, it's always a lot of labor. If you are interested in these things we're doing and you live in Olmos region, we're certainly hiring for capable people. Give me a call, send me an email, you can stop by for a chat and we'll see if we would work together.
Straight to the face. Good shot, Henry. That was a good one.